So in this section, we're going to be talking about two types of tangent vectors at a specific point t on a vector value function. We're going to be talking about these normal unit tangent vectors, and then we're going to be talking about the principal unit tangent vector, or the principal unit normal vector, excuse me. So first let's talk about what a tangent vector is, a unit tangent vector. Unit vector has magnitude 1. And tangent vector is going to be the vector tangent at a specific point. And essentially, all we're going to do to define this as capital T, a vector of t, then we're just going to go ahead and take the derivative of the function and divide it by the magnitude of the derivative. And that's going to give us our unit tangent vector t of t. All right. Now notice that r prime at t cannot be equal to 0, otherwise it won't be smooth at that specific point. So that might be the first thing that we have to do, is verify it's smooth, and then we can go through and do the rest of what's necessary. So let's take a look at an example of this. So for each curve and the point given on that curve, or each of the vector functions, let's verify that the curve is smooth, let's plot it. Then we're going to find the unit tangent vector. In other words, we're going to find t of t at the given point, and we're going to graph the unit tangent vector. All right, so first of all, to verify it's smooth, or I, not A, excuse me, because A is the problem, then we just remember we find r prime of t, which is going to be 2ti plus 2j. And r prime at 1 is going to be 2i plus 2j. Clearly that's not equal to the 0 vector, and it clearly exists, so it is smooth. All right, so if it wasn't smooth, no need to do the problem, because if it's not smooth at that point, then the unit tangent vector does not exist. Okay, we're going to plot the curve. Now to plot the curve, we're going to parameterize it. X equals t squared. Y equals 2t, okay, and we're going to eliminate the parameter, so y over 2, or we could do this one of two ways. I'm going to solve this for x. Now it's not going to be a function, right, but that's okay. So we're going to get square root of x is equal to t. All right, and remember that t is greater than 1. Actually, at this point, t is equal to 1. So technically, we don't have to worry about the plus or minus. So in reality, it's plus or minus t, but we're just going to worry about the positive. All right, since t equals 1, all we're going to worry about is root x is equal to t. All right, and we're going to substitute that back in. So we're going to say that y is equal to root x of t, or 2 roots of x. Excuse me. Right. We're just going to plot that, and then we also have to graph the orientation of this. Right. So on a curve, so a couple points we would have are 0, 0. We'd also have to have 2 or 1, 2. So if I'm just plotting this, and then if x was 4, then that would be 4 as well. And so we have this point, and then we have 1, 2. So we're starting to get a curve, a vector function that looks like this. Okay, just our regular square root function. And notice that I did plot a couple of these points. So right here, that's the point when t equals 1. So we get the point 1, 2, or x equals 1. And then over here, we had that t was equal to 2. So we ended up with the point 4, 4. So right here, t equals 2. And at the origin, t equals 0. All right, so it looks like the orientation is following that path. Okay, so don't forget that whenever we try to graph a vector value function, we also try to plot its orientation. Now there's another half to this function that's below the x-axis, but in this case we don't worry about it because we're just worried about t at 1. All right, so now that we have this, we're going to find t of t. Okay, so part 3, we're going to find t at t, which is going to be equal to r prime of t divided by magnitude of r prime of t. And in reality, we just need to find r prime at 1. All right, so really, t at 1 is going to be equal to r prime at 1 divided by magnitude of r prime at 1. Right? And remember, we had that up here. Okay, so we have r prime at 1 is 2i plus 2j. And then we just divide that by the magnitude, which is going to be 2 square plus 2 square. That's going to be 8. All right, so t at 1 is going to be equal to 2 over root 8 I plus 2 over root 8 j. And we know that 8 is the same thing as 2 roots of 2. So really we can rewrite this as 1 over root 2i plus 1 over root 2j. Right? And 1 over root 2 I believe is 0.707. I'm just going to verify that in the calculator really quickly. Yep, 0.707. So that's really 0.7. All right, so I'm going to approximate that as 0.7i plus 0.7j. Right? And the reason we need that is because we need to graph this unit tangent vector, although this is what we really care about for t of 1. Right, so we're going to go back up, and t of 1 just tells us that we have to move, and this is part 4, so where we're asked to be able to plot this. So we're going to graph the unit tangent vector on the same graph as the original curve. So we're going to go down here, and we're just going to move 0.7 and 0.7. So we're probably going to move to the right a little bit and up a little bit. And so we get this sort of shape. Okay, so this is the terminal point, and that's our vector. Okay. Now I want you to notice that we're not moving 0.707 or 0.7i, 0.7j from the origin. It's 0.7 from that point. Okay, so this is t at 1. Right? Now a little bit later, we're going to find the normal vector, okay, or the principal normal unit, or the unit principal vector that's going to be normal to that. But for right now, all we're worried about is being able to find this tangent vector. Okay. All right. So go back through, look through this again. I'm sure the mechanics aren't too difficult, but just being able to understand how to plot and then be able to work with this unit tangent vector, and then watch the second video. Maybe even try to work the problem beforehand, so that way you get an idea as to how to how much you know and how much you don't know with respect to these unit tangent vectors.